Hello everyone, this is the fourth video on electrolysis, and in this video we will discuss some examples of electrolysis. As you know, in previous videos we have discussed what is electrolytic cell, mechanism of electrolysis and characteristics of electrolysis. Now in this lecture we will discuss examples of electrolysis. So the first example of electrolysis is electrolysis of molten lead bromide. Now the things that you have to remember during the process of electrolysis in the examples of electrolysis is, number one, the electrodes, which is cathode and which is anode, means what type of electrode is cathode and what type of electrode is anode. The second point that you have to remember is the electrolyte, which substance is going to be used as an electrolyte. So the substance whose electrolysis is taking place, that substance will be used as an electrolyte. The third thing that you have to remember is the reactions, reaction at cathode and reaction at anode. So these are the most important things which are asked in the examination. So you have to remember these things. Cathode is made of which material, anode is made of which material, then second, which substance is being used as an electrolyte, and the third, the reactions that is going to take place at cathode and anode. So the first thing, electrodes. So which are electrodes here? You know there are two types of electrodes, one is cathode and other is anode. So you must know which substance is being used at cathode, that is graphite. So you know that graphite is an inert electrode and anode is also made of graphite. So two rods of graphite are used at cathode and anode. Now the electrolyte that is being used here, electrolyte is molten lead bromide. So that is molten lead bromide. Then the third thing that is asked is reaction at electrodes. The first is reaction at cathode. So before the reaction at cathode, you must know the process of electrolytic dissociation. So the formula of lead bromide is PbBr2, and you know when it is heated, the lead and bromide ion will get separated, so it will form Pb2 plus and 2Br minus ion. Now you know that at cathode positive ions migrate towards cathode, so Pb2 plus ions will migrate towards cathode, and negative ions, that is bromide ions, so Br minus ions, will migrate towards anode. So what reaction will take place at cathode? At cathode reduction takes place, so Pb2 plus will gain 2 electrons and will form Pb. So reduction will take place at cathode. Now which reaction will take place at anode? Oxidation, so Br minus, so 2 Br minus ion will lose 2 electrons, so they will form 2 Br plus 2 electrons, because bromine atoms will lose the electrons, and also Br plus Br, that is 2 Br will form bromine molecule. So you can see this is reaction at cathode and this is reaction at anode. So at anode oxidation will take place. So during the electrolysis, whole other processes are same in the process of electrolysis. So you can see when the current is drawn in the electrolytic solution, what will happen? The lead ion, positive lead ion, will migrate towards cathode. They will get neutralized there. Negative ion, we have only bromide ions. Bromide ions will migrate towards anode and they will lose their electrons there, so they will form bromine molecules. Now one more question is asked, what is the product obtained at cathode and what product is obtained at anode? The product obtained at cathode is lead and the product obtained at anode is bromine. So this question can also be asked in the exam. So this is all you have to know about the electrolysis of lead bromide. Other things that DC is used will be same in all the processes of electrolysis. Next example is electrolysis of acidified water. So to make water acidified, we use sulfuric acid. So the acidified water is basically very dilute sulfuric acid. So you have to remember this, it consists of sulfuric acid. Now the things that you have to remember, the first thing is nature of electrodes. So electrode. So what kind of electrodes are we using? Anode. Anode is made of platinum. So generally platinum foil is used at anode, and at cathode again we use platinum foil. So again we are using inert electrodes. Then the second thing that you have to remember, that is electrolyte. So electrolyte is, what is electrolyte here? That is acidified water, or you can say sulfuric acid, because we are using sulfuric acid as an electrolyte here. The third point that we are going to discuss is reaction. So before reaction, again we have to see the dissociation of H2SO4. So H2SO4 will form 2H plus SO4 2 minus ion, right? Also because it consists of water, so water forms a very small number of H plus ion and OH minus ion. So this is what happens in water. Water will also dissociate into H plus and OH minus ion. However, a very small number of water molecules will dissociate into H plus and OH minus ions. So you can see there are positive ions and negative ions. Now you can see for positive ions we have only one option, that is H plus ion, and you know that positive ions will move towards cathode. Here we have to use selective discharge, means which of the ions will move towards electrodes. But in case of positive ions we have only one option, so that ion will move towards cathode. So what reaction will take place at cathode? So H plus ion will migrate towards cathode. So 2H plus ion will gain 2 electrons at cathode and it will form 2H atoms. So this is the process of reduction, obviously. Then the second thing, these 2 atoms of hydrogen will combine to form one hydrogen molecule. So product obtained at cathode is hydrogen gas. It means this inverted tube will consist hydrogen gas. Now what happens at cathode? So this is reaction at cathode. Now what happens at anode? So let's see reaction at anode. So we have 2 negative ions here. That one is sulfate ion and other is hydroxyl ion. Now we have to select an anion which will migrate towards anode. You know, according to selective discharge, this is least preferred for oxidation. So OH minus ion will migrate towards the electrode, that is anode. So OH minus ion will migrate towards anode instead of sulfate ion. So what will happen? 2 OH minus ions will migrate towards the anode and they will form 2 OH plus 2 electrons. Now you can multiply this reaction by 2. So 4 OH will form, if you will multiply this reaction by 2, so we will get 4 OH and 4 OH will get convert into 2 H2O plus O2. So which gas is obtained at anode? That is oxygen gas. So what are the products of electrolysis? Hydrogen and oxygen gas. Hydrogen gas is obtained at cathode and oxygen gas is obtained at anode. So this is the electrolysis of acidified water. So you can see water is obtained again and concentration of H2SO4 will remain as it is in this process. So only the electrolysis of water is taking place, because at cathode H plus ions are getting neutralized, while at anode OH minus ions are getting neutralized. So in overall reaction, the electrolysis of water taking place, or you can say that sulfuric acid is being used as a catalyst here. So remember, a question may be asked that how the sulfuric acid acts as catalyst in the electrolysis of acidified water. So basically water is going for electrolysis while concentration of sulfuric acid will remain as it is in the solution. So sulfuric acid is acting as a catalyst in this process, because sulfuric acid is being used to increase the concentration of ions, while the water is undergoing electrolysis, not sulfuric acid. The next example is electrolysis of copper sulfate solution using copper electrode. So what will happen if you use copper electrode? Copper electrode is an active electrode, and I have already told you that active electrode affect the process of electrolysis. So you can see the setup that anode and cathode both are made of copper. So first question, that is electrode. Electrodes are cathode, that is copper, and the second is anode. Anode is also made of copper. So the first thing is clear to you. Electrode, cathode is of copper and anode is of copper. The second thing is electrolyte. So what are we using as an electrolyte here? That is copper sulfate. Copper sulfate is being used as an electrolyte. Then the third thing, that is reaction at cathode and reaction at anode. So before this we will see copper sulfate will form Cu2 plus SO4 2 minus ion. You also know that water will form H plus and OH minus. Now reaction at cathode. So the competition is between H plus and Cu2 plus, because there are two positive ions and positive ions will migrate towards cathode. They will get reduced at cathode. So either it is H plus ion or Cu2 plus ion. So which ions will that be? Let's see, because copper ion can get reduced more easily as compared to H plus ion. So it means copper ion will migrate towards cathode by gaining 2 electrons and it will form copper here. So the product that is obtained at cathode is copper. So reduction will take place at cathode. Now in this case there is a different type of reaction will take place at anode. So remember, reaction at anode. You know that what happens at anode? At anode oxidation takes place, but because there are two ions, one is sulfate ion and other is OH minus ion. Again, because sulfate ion cannot get reduced, OH minus ions will not reduce here. The substance that will get reduced here is copper. So at anode copper will lose 2 electron and will form copper ion. So this process will take place at anode. So remember, reduction will take place at cathode and oxidation will take place at anode. So at anode copper. Now why this process is happening differently? Because this time we are using active electrodes. These are active electrodes. So active electrodes are those which participate in the electrolytic reaction. So these substances, that is copper is participating in electrolytic reactions. So therefore these electrodes are called active electrodes, and you can see these electrodes are affecting the reaction at anode. So you can see at anode what will happen, the copper from the electrode will get into the electrolytic solution and form copper ion and will lose 2 electrons. So the copper ion will migrate towards cathode and will form copper metal. So you can see anode will continuously keep losing Cu2 plus ion. So because it will continuously lose copper from here, it will get thinner and thinner. So because it is being consumed, so it will get thinner and thinner as the reaction proceeds. But what will happen at cathode? At cathode, copper is deposited on the electrode. So the cathode will get thicker and anode will get thinner during the process. As the process proceeds, the anode will become thinner and the cathode will become thicker. Why? Because at anode, copper is being consumed. Copper is forming copper ion, and this copper ion will migrate towards cathode, and this process keeps going on. So remember, if the question is asked, what is your observation? What do you observe during the electrolysis? So we observe 3 things. First thing, that the size of anode will keep decreasing. Second thing, the size of cathode will keep increasing. And the third thing, that is electrolytic solution. So generally you know that the solution of copper sulphate has blue color. So it will maintain its blue color. Why it has blue color? Because of the presence of copper ion. But copper ions will migrate towards cathode. At the same time, the copper ions will form at anode. So the balance will be maintained. Balance of copper ion will always be there. The amount of copper ions in the electrolytic solution will always remain same. They will not decrease. So because copper ions are there in the solution, so it will remain blue. The next thing, one more question can be asked, what if we use inert electrode instead of copper electrode? For example, what if it is not copper electrode but carbon or graphite? So graphite is inert electrode. So what will happen if we are using graphite, not copper electrode? So remember, reaction at anode will change because we don't have any copper at electrode. So what will be the reaction at cathode? Reaction at cathode will be same. And reaction at anode, because out of sulphate and OH minus ions, these OH minus ions will move towards the anode and they will form 2 OH plus 2 electrons and again 4 OH. If you will multiply this reaction by 2, it will become H2O plus O2. So you can observe oxygen gas at anode in this case. Now, since the copper ions get consumed from the copper sulphate solution, there will not be any more copper ions in the solution after the reaction proceeds. Since copper ions are migrating towards the cathode, so the concentration of copper ion will keep decreasing in the solution, and as a result, the blue color of the solution will get faded as the reaction proceeds. So you also have to remember the observation. If we use an inert electrode instead of copper electrode. So there will be two differences. The first, the blue color will get faded, and the second thing, the reaction at anode, that will be different from the first case if we use an active electrode as copper, right? So you have to remember these points. So this is all in this lecture. If you have any queries, you can ask your questions in the comment box. Thank you very much.